Now, another name for percent error is percent yield. Let's unplug. Okay. So percent error, percent yield, it's going to be the same thing. All right? Get off the phones. Jordan. Okay. So really what you're looking at here is what's the difference, how close are you to the actual value that you're supposed to have in that experiment. So when you do your experiment, you get a result, and that result is what you got personally, right? Yep. The theoretical, the actual is what you were supposed to get. Yep. Okay? So this percent yield is going to show you how far away you are from the true value. Okay? So look at, let's do what? Let's just do number one.
No, number two.
No, number two is just with the exponent. That's it. Let's do number one. Okay, so my accepted value is the 1.30 grams. And then you're going to subtract your experimental value, which is the 1.24. Now, is every problem going to give it to you like this, where it's all given?
No.
No. So they might give you like, okay, so-and-so made this experiment, this was their result, and your theoretical value is this. So you have to recognize that the theoretical value is your accepted, and then what they got in their experiment is that number. Okay, so here we're going to divide by what? You're going to subtract these two, 1.3 minus 1.24, right, equals, and then you're going to divide by what? The 1.3, because that's your actual value, right? Okay, then equals times 100. Now don't forget to show the work. What is your percent going to be here? Calculators are up here. You need to leave an ID or something for it. Okay, no. Mijo, stop with the silliness. Okay, and leave that in there. I don't want to hear that anymore. Start being polite. 99? Is 99? Okay, so you have 99%. So, were they pretty successful on this experiment?
Yeah.
Yeah, they're pretty close. Now, is it possible for you to get a negative number because of absolute zero? Yes. Okay. All right, that's it. That's all you're going to do. On the flip side, you're going to do mass to mass. If you have a question on one of those, give me one of those, and we'll go over it.
Number one.
Number one. Okay. So what is it that they're giving you on number one? Really, we want to pick number one? Are we sure?
Nah, number two. Well, which one's the hardest? Which one's the hardest?
It depends on what you guys, that's a little bit of everything. It's a mixture of everything. This is what you're going to be tested on tomorrow. It's a mini review of everything you're going to have tomorrow.
Let's do 5.
Number 5? That's a good choice. That's a mass to mass. Okay, so let's do number 5. What's my given?
100 grams of C2H2.
100 grams.
That is 110. What?
Okay, 100 grams. All right. And then you're going to do what? What is it that I'm looking for?
H2O. How many grams of water?
I'm looking for grams of water, okay? And that's what my unknown is, right?
Yeah.
Now, look at that equation that you have on top. You're going to need those coefficients to do that. But first, what do I need to do to this given right here?
See how many moles are there.
You have to find the moles. Very good.
Yep.
And how am I going to do that? You're going to divide by the molar mass of the C2H2, right? And so carbon weighs?
16.
No?
12.
It's 12. Very good.
24.
12 times 2 is 24. Hydrogen weighs how much? 1 times 2 is 2. So what's my molar mass? 26. Okay, and what's going to be on top?
1 mole.
The 1 mole of C2H2. And this is going to give you the moles of C2H2. Are we finished?
Negative.
We're not finished. Very good.
No, Chris.
So what's your next step?
Well, first you gotta pick what that is.
You can. If not, you can put it all together. Some people put it all together.
I'm sorry.
Either way.
Then you gotta put the coefficients.
Right. 100 divided by 26. Okay. 3.8. Is that what we got? Okay, so you got 3.8 moles of C2H2, right?
Yeah.
Okay, now you're going to do what Aiden was saying. You're going to do the mole to mole, because now you're going from the C2H2 to what?
H2O.
To the H2O, because you're looking for water.
Yep.
So my mole of C2H2 goes on the bottom. And what's going to go on top?
Mole of H2O.
H2O. Very good. Because you're trying to get rid of this chemical. Now, these two numbers come from those coefficients. What's my mole for water?
2.
2. What's my mole
2.
for... Okay. Now, wait till I finish so everyone else can listen. Okay? Okay, and it is 2 moles of your C2H2. All right. So now, are we finished? No, because we're looking for what? You're looking for the grams. Okay, so once you do this, this really comes out to 1, right? So 3.8 times 1 is still the 3.8. So you have 3.8, but now it's moles of water. How can I find my grams?
You multiply by the moles.
Yep, very good. The molar mass of H2O is going to be on top. What's going to be on the bottom? 1 mole of H2O, because we're going to get rid of the mole. And now what's my molar mass that goes in here to get my grams? Yep, because oxygen is 16 plus the 2, that's 18. So now 18 times 3.8, how much?
68.4.
68.4. Very good. Now that's the longest problem that you're going to have, a mass to mass. Everything else is going to be shorter. You could just have mole to mole, which means you're just, let's turn off those phones, which means you're just going to do this part. Okay? Or you can go from moles to mass, or you can go from mass to moles. Okay? And this one's mass to mass, this particular problem. Okay? All right, go ahead and get started. You're going to do the percent composition first. The percent yield first, the other side. And then you're going to do this side, this review. You're going to work on your own. You can use anything, the notebook, calculator, anything you need to get that done.